Now we come towards the applications of the centrifugal forces. Normally its main application is in centrifuge. So centrifugal pump used to lift the water works on the principle of centrifugal force. A cream separator used in the dairy works on the principle of centrifugal force. By churning the cream, we find that the butter goes to the separate portion. Centrifuge used for separation of suspended particles from the liquid works on the principle of centrifugal force. Now we come towards the construction of the centrifugal force. So it is clear from the figure. The centrifugal force of two steel tubes suspended from the ends of the horizontal bar, which can be rotated at high speed in a horizontal plane by an electric motor. So this is clear from the given figure that there are two steel tubes and they are fixed at the ends of the horizontal bar. Now next thing is the tubes are filled with liquid and the bar is set into rotation. Due to rotational motion, the tubes get tight and finally becomes horizontal. Now due to heavy mass, the heavier particles experience more centrifugal force than that of liquid particles. Now we consider an example for the centrifugal and centripetal forces. The two balls of equal masses are attached to the string at distance 1 meter and 2 meter. One end is shown in the figure. The string with masses is then moved in a horizontal circle with constant speed. Find the ratio of the tensions in the string. Now you can check the figure, that is T1 and T2 are the tensions, that is for 1 meter and 2 meter string. So we will first of all suppose the radius. Let the radius of the two circles be R1 and R2. The linear speed of the two masses are V1 and V2, and V1 is equal to omega R1, V2 is omega R2. According to formula, V is equal to omega R, where omega is the angular speed of the circular motion. The tension in the strings are such that, now we find first of all first tension, that is mv2 square by r2, or it is m omega square r2. Now if we take T1 and T2, the difference of the two numbers, we put the value of T1 and T2 and simplify the result, that is m omega square r1. So T1 is equal to m omega square r1 adding to T2 and got the calculated result. And from that we got the value of T1 over T2, that is R1 plus R2 over R2, and that is equal to 3 by 2 by computing the values. Now we come towards a circular loop. A circular loop has a small bead which can slide on it without friction. The sides of the loop is R. The radius of the loop is R. Keeping the loop vertical, it is rotated about a vertical diameter at a constant angular speed. What should be the value of angle theta when bead is in dynamic equilibrium? Now centripetal force is provided by horizontal component of the normal reaction N. The vertical component balances the weight and horizontal component, that is taken as the vertical component balances the weight. Therefore, N sin theta is equal to m omega square x, and n cos theta will be mg, because mg is balanced by n cos theta and the normal reaction is balanced by n sin theta. Also, x is equal to r sin theta and n is equal to m omega square r. From this we can get the value of cos theta, which is found to be g over omega square r, or theta is equal to constant, that is the cos inverse g over r omega square. Now we come towards the practical application of the circular motion. However, we have discussed earlier, that is the motion of planets around the sun and the motion of electron around the nucleus. Now we come towards a special case like cyclist making a circular turn. when cyclist makes a circular turn. You can refer the figure. That is, R is the radius. R is resolved into two components. One is R sin theta and R cos theta. The R sin theta is balanced by mv square over R, but R cos theta is balanced by mg. So, by using this figure, we will find like this. Let a cyclist moving in a circular path of radius r bend away from the vertical by an angle theta. If r is the reaction of the ground, then r may be resolved into two components as I have explained you earlier. One of them is horizontal component and other is vertical component. So, the vertical component r cos theta balances the weight as I have explained just now, and r cos theta balances the weight mg of the cyclist, and the horizontal component r sin theta provides the necessary centripetal force for circular motion. So, r sin theta will be equal to mv square over r. You can refer the figure. R sin theta is mv square over r. R cos theta is mg. If we divide the two numbers, we get vrg in terms of tan theta. Now check the figure. A cyclist is bending. The same principle can be adopted. There is a weight is acting vertically down mg. R cos theta is the reaction, and R sin theta will be another reaction, and that is balanced by mv square by r. For less bending of the cyclist, his speed should be smaller and radius r of the circular path should be larger. Now, if mu is the coefficient of friction, then for no skidding of the cycle, the formula will be mu greater than equal to tan theta. We have derived in the case of friction, and mu can be estimated as greater than equal to v square over rg. Now the figure is shown. Again, the same figure is depicted. The cyclist is bending, and when it bends, the angle made by the ground will be theta. So mv square by r will be balanced by r sin theta, and r cos theta will be balanced by mg, where r is the that is reaction or the weight. An aeroplane making a turn. Now see the aeroplane, it is making a turn. A plane must roll at some angle theta, in which manner that is the horizontal component of the lift force. L provides the necessary centripetal force for the circular motion. We are referring to L. L provides the necessary centripetal force for the circular motion. The vertical component of the lift force balances the weight of the plane. So vertical component is L cos theta. It balances mg, and L sin theta, that will be the vertical component. L sin theta is balancing the mv square over r, that is the centripetal force. And L cos theta is equal to mg. If we divide the two numbers, tan theta will be equal to v square over rg, and from this we can get the value of theta. Or v square is rg multiplied by tan theta. Now we have an example. 1.2 kilogram block slides on a horizontal frictionless surface in a circular path. Wherever we use a term circular path, centrally directed force, centripetal force, will come into action. And at the end of 0.60 meter along string, calculate the block's speed if the tension in the string is 72 newtons. By what percentage does the tension charge if block speed decreases by 10? Now see another figure and another diagram. 1.2 kilogram block slides on horizontal frictionless surface in a circular path. So in order to solve this question, we have to first of all go with the force diagram of the block as shown in figure. The upward normal force balances the block's weight. The tension force of the string on the block provides centripetal force that keeps the block moving in a circle. The Newton's second law for the force along the radial direction is F is equal to mass into acceleration, or we will say F in radial direction is tension, that is mv square over r. We can write this equation as V is equal to T into R by M. T into R by M. That is what we calculated from T is equal to mv square by R. And then we computed the values, and value calculated to be 6 meters per second. Now you can again see the figure. Like in the figure, it is radially inward. Tension is radially inward. Fn balances W. And 10% reduction in the speed results in the speed. So 10% reduction means that new velocity will be 5.4 meter per second. New tension will be mv square, or new tension will be T dash is equal to mv dash square by r. Then we computed the values and we got the value of T dash by T, which is found to be 0.81. The percentage reduction in the tension is about 19%. The same result is obtained by using proportionality method, that is T dash is replaced by mv dash over r, T is replaced by mv square over r. So m will cancel off, r will also cancel off, v dash over v square we get, and then we compute the values of v dash and v. This is found to be 0.81.